plants that are being grown in containers in your house. Because in your house, the only water the plant gets is the water you give it. And when you fertilize it, especially if you put something underneath it to catch the water that drains through, then the water goes back up, moves back up through the soil. Depending on what types of fertilizer you're using, you can actually get salt buildup in your soil in that plant, in that container, in the house. So that leaching applies in our area to plants being grown in containers inside, because if you grow, and you know what everyone in here knows, if you grow in containers outside, we get close to 60 inches of rain a year. If you go out there and irrigate, you actually, you have your drainage holes in the bottom, so if you irrigate deeply, then you almost always have water coming out. So if you're growing them in containers outside, you really don't need to be worried about leaching. You're not going to have any salt built up unless you're really putting way too much fertilizer in it. So with that on the soils, I'm going to point that out because that quote rule of thumb for leaching applies only to your interior plants here in our area. But it is in the video and it doesn't make that clear at all. And so I want to address that. And then answer any questions, if anybody had any questions about the soil.
How often do you have to do that?
If you're on the inside,
Yeah.
about once a month, unless you aren't fertilizing very often. But if you do it once a month, that's a good rule of thumb. Yes?
I was curious to the reading, it mentions that tilling the soil adds aeration, but it also leads to nutrient loss. And I was just wondering where the current thinking is around, like, no-till gardening practices and green composting.
Okay, so the question was that tilling the garden aerates it, but it also leads to nutrient loss. She's wondering what the current thinking is on no-till versus tilling. And no-till works really well if you got your soil in good condition. But if you're trying to grow soil and you don't have sufficient organic matter, or the texture of the soil is way off, if you got a lot of clay in there or something, no-till over the course of time, it's going to get really packed and hard, and you're going to have to do something. But if you have good organic matter in the soil, it's got good drainage, the texture is there, about a sandy loam type soil, and you're adding organic matter on a yearly basis, then the no-till works really well. Just be aware that if you take really good care of your garden, keeping the weeds out, but your neighbor doesn't, no-till, you're going to get weeds in there, and so you'll have to come up with some way of controlling those, with some type of a weed barrier, mulch, or a weed cloth, something like that. But it's definitely better to do the no-till. And tilling, you mentioned it aerates the soil, which is really good, but you can lose some nutrients. What tilling also will do is will reduce the microflora and microbiota in the soil. And it has to then build its population up again. Did I answer the question?
Yeah.
Okay. Yes?
How do you add nitrogen back to the soil again?
How do you add nitrogen back? You add nitrogen to the soil by using nitrogen fertilizers, and those can be chemical fertilizers or organic sources of nitrogen. And so you're adding nitrogen that way. And if you're adding composting material to your organic matter, you're also adding some nitrogen. Now, there's articles in the Geno Gardening newsletter. I hope everyone's getting it. If not, they can get it. There was an article a couple of months ago. Anna wrote an article on compost and its benefit to the soil. And compost, don't ever really think of compost as fertilizer, because the nutrient value in the compost that actually is available to your plants is very low. In a really good compost, there might be roughly 3, if it's a really, really good one, there might be 5% nitrogen in it. But of that nitrogen, the majority of it is locked and bound in complex chemicals. It's still bound within that organic material that's in the compost. And it's only made available once microorganisms start to break it down. And so if you have compost, let's say it's 4% nitrogen, under analysis, only about 3% of that is actually available to the plants when you put the compost in there. And then it slowly released over time, so it's a slow release form of, very small amounts of nitrogen. Yes, Richard?
So if you're raising worms and you get the all the worm castings, is that the same thing where it's not as available to the soil and the plants as,
As standard compost. Vermicompost is the same situation. It's still bound and locked within that broken down organic matter. The microorganisms, or going through the worm's digestive system, and the microorganisms in their gut, starts to break it down into smaller units, both physically and chemically. However, the compost itself, most of the nutrients are locked within the matrix of the compost. And it's the same thing with organic fertilizer. Just an example, blood meal. Excellent organic fertilizer. And I think it's, analysis, I think it's 18% nitrogen. But that 18% nitrogen that you have in the blood meal, it is in a complex form. And only about 3% of that 18% is available for your plants. Might be 5% of the 18%. So if you do 5% times 18%, you see that's really a small amount. So you really aren't giving your plants as much as you think when you're using organic fertilizers like that. They are a slow release form, and over the course of, in our area, probably 3 months, in some other areas, roughly 6 months, all that nitrogen in the blood meal will be released. But you can see that's over a long course of time. Now, or the chemical fertilizers, if you use those, they're in the form that plants like. Plants only take up nitrogen in 2 different forms. It's primarily nitrates, they'll also take it up as ammonia. That's the only way they're going to take up nitrogen. And the plants don't care where that nitrogen comes from. They don't care if it comes from the chemical fertilizer that you add, or if it comes from blood meal, or if it comes from the compost. Plants, it makes no difference to the plant because they can only take it up in those forms. And so that's what the organic material is being converted to. The nitrates and the ammonia by microorganisms in the soil and making it available then to the plants. But the chemical fertilizers, they come formulated in that water-soluble nitrate form. Most of them are in the form of nitrate. So if you use a chemical fertilizer that's 18% nitrogen, boom, all of that nitrogen is immediately available to your plants. And that's why with chemical fertilizers, you can actually burn plants by putting too much fertilizer, because those are acidic forms of the chemicals, and that's what's actually burning the plant. And so you can actually burn plants with too much chemical fertilizer. It's really hard to burn plants with too much organic fertilizer. There is the organic materials you can add, like hot or raw manures. If you add those, they can burn plants. And they should actually you should never use manures, raw manures, unaged manures, or uncomposted manures in your garden. I mean, people do it, you can do it, but it's a better idea to always have it aged or composted for 2 reasons, because then the material is not going to burn your plants, it's not going to be hot, and safety reasons. The U.S. has some rules and regulations, especially for commercial producers. They can never use raw manure of any kind if they're growing something it's edible. If they ever use raw manure, then they have to wait up to 120 days before they can harvest. So if you were using that type of stuff on your tomatoes, you might as well throw them away, because you never know how anything to harvest to sell. And it's a safety precaution because of the microorganisms that are in the manures.
So that's the same with manure tea? You just want to, so it's still too strong?
Manure teas, if you make them from raw manure, would have the same caveat to it. Manure teas made from composted manure is different from that, because it's already been aged and broken down and composted, and so those teas aren't the same. Any more soil questions?
I have a question.
Yes.
So this isn't for me, but it's for a friend of mine who is very interested in growing an orchard. They live in 3 acres of land on the Mississippi-Louisiana border. It's mostly clay, like sandy clay, with kind of like a very thin layer of decent dirt on top, but they're trying to figure out a way to make the dirt more usable for growing plants. So basically, they're learning.
Mhm.
What advice would you have?
Okay, did everybody hear the question? It's an area where they're wanting to start an orchard. It's mostly sand and clay with a small thin layer of topsoil. And they want to improve the soil for growing an orchard. So they're going to be planting trees in that. And the best way is to add a lot of organic matter to lighten the soil, and if they can do anything as far as bringing in high quality topsoil to add, that would improve the depth of the growing layer. And now the trees can grow quite well in if the sand, it's mostly sand with clay, if it drains well, they can grow quite well in there. And adding the organic matter will improve the soil over time, but in that type of soil, you're going to need irrigation because the drainage is going to be really good and the trees may dry out. And with the clay in there, any fertilizers you add are going to be held because clay improves the CEC of the soil. And so that is a good thing to have clay in there, as long as it's not so much that it starts to inhibit the flow of water through the soil.
It's easy for the fertilizer, like a little raised bed or something to add organic matter. What would you recommend for 3 acres? What kind of organic matter would you put in?
Bulk arborist chips. If you use chipdrop.com or reach out to local arborists in that area, have them dump all that wood mulch that they're producing. Typically they'll give it away for free or charge a small tipping fee. But we have a grower on the West Bank that grows vegetables, and it's a very sticky clay soil. That's what they did. One of their neighbors was an arborist. Every dump truck load, they'd spread it out with a tractor. They did that for about 3 years, and now they have really nice dirt. So that's a good free resource rather than paying $60 a yard or whatever you're gonna find for topsoil.
Bulk arborist chips?
Yep.
Okay.
So reach out to, get that phone book out up there, find the arborists in the area and call them up and say, hey, you can come tip your arborist mulch for free. Yep.
There's somebody in Mississippi that is doing that. I mean, they're doing it on Facebook. If you look on Facebook, they're giving out all their wood chips.
Yes, you can do the same thing.
Repeat the question.
She was asking if you could do that for raised beds. Absolutely, that's how I did it at my house. It takes a few years for that to break down and you still need garden soil and compost on top, but that's a really great way to build your beds. And I think for our garden planning section, we're gonna do something very similar with the hugelkultur. It's the same principle. Locally, Entergy gives away wood chips, that chipdrop.com, and then if you reach out to the arborists kind of working in the area, you can get on their list, and if they're working in your neighborhood, they'll come jump it. You have to have somewhere for a lot of material to go though. So like an empty lot, like I got 20 yards once and it was too much. So that's the kind of volume we're talking about.
Can you repeat? I couldn't quite, you talking about wood chips?
Wood chips. So anytime an arborist cuts down a tree, they're grinding all that material up into smaller particles. That will turn into compost and organic matter eventually. If they were to take that to the dump, they're gonna have to pay a fee to get rid of it. So they really like it when people like us call them up and say, hey, I can take some of that, because it saves them money.
I have a question. So if you're removing a stump, a tree stump, aren't you supposed to remove it from the ground? Because if you leave it in there, the rot, I mean, from what I understand, it causes lots of sinkholes and
It can.
rots, and then it's not good for the garden.
So usually if you remove a tree and the stump remains, they will grind it and it turns into wood mulch. And my friends lost a tree in that last storm and now they have a sinkhole in their yard. You have to bring fill dirt in for that, but they're not gonna haul that stump away, unfortunately.
No, but what I'm saying is, so it is good for your yard to remove it completely.
Well, it depends. If you're gonna plant a garden in that spot, you might wanna leave it.
So leaving it is good for the
But
garden.
remember, said,
They
take the
grind
wood
it.
chips and you're adding topsoil and you're adding compost to it.
Yep.
Because if you just put uncomposted wood chips into your soil, they will break down, but the microorganisms that break it down, they get first dibs on the nitrogen. And so as soon as they turn that wood chip into nitrate forms or ammonia forms that the plant wants, they take it and use it for themselves. So uncomposted material mixed into your garden is not good because it does
Yep.
start to use up the nitrogen.
So the chips that you leave on top of you, mixing it in.
Bottom. Put them on the bottom. Unless you're doing 3 acres, that's really impractical. Then you let them rot on the surface for a few years. And you let them break down naturally. We're going to talk about that in garden planting and in the organics chapter.
Probably in
And,
compost.
and probably next week in composting, we'll circle back around to that. But yeah, the wood chips, a lot of the raised beds we see locally, people buy garden soil. That garden soil is mostly wood trash and arborist chips, and that's why they have to add so much nitrogen or they fail as gardeners. The plants are spindly and yellow. We've all seen this. It's because of that wood material. So you have to put it in the right strata of the soil, and we're going to cover a lot of that in organics. All right, Joe.
Okay.
I have a question.
Yes.
So, for the legumes that can increase nitrogen as a cover crop, could you also use them in tandem with plants that aren't getting enough nitrogen? So, like, say you have a plant that you're like, oh, this needs nitrogen, but neither of the processes aren't working. Could you plant it next to it and help it grow, get nitrogen that way?
Okay, the question was, if you're growing legumes, really don't need nitrogen fertilizer because they have the relationship with the rhizobium and the nodules, and those bacteria take nitrogen out of the air, turn it into nitrate, which feeds the legumes. So they don't need nitrogen the way a lot of other plants do. Now, since the legumes do that, can you plant legumes in with your other plants and they'll provide nitrogen for those plants? And the best answer is no, they do not, because what they're doing as a cover crop, as growing in the garden, those rhizobia and those nodules are taking nitrogen, turning it into a form that the plant can use, and then that legume is using that nitrogen. So it's making its own nitrogen fertilizer, and it's using it. There is a small amount of leakage in some legumes into the soil, but it's not significant based on any research that's ever been done to actually provide nitrogen for plants growing near it. The way they increase the nitrogen level in your soil is, as a cover crop, you aren't having to fertilize them with nitrogen. The bacteria are doing that for you. The plants grow, they have lots of nitrogen stored away in them as they grow and make leaf material and all that. And then you plow that under. It becomes green manure going into your soil. Now that nitrogen, which they have been fixing and making, becomes part of the soil and gets broken down and released. But while they're alive and growing, the nitrogen that they're making or that the bacteria are making is going for them and not for other plants around them.
And in a no-till system, you would weed whack it and let it rot on top. And here it works really good in the summer months. We use clay peas and cow peas. You can plant them now. And we're going to talk about that in organics too. You want to start the lab, Joe?
Look it up. There any more questions?
My friend says thank you.
Oh, good. We're going to go ahead and start the labs. We have two labs, two soil labs we're going to work on. The first one is determining your soil texture. So what is soil texture? Quick definition. Tell me. Okay, size of the aggregate? No. What is, when you, see, these are kind of, why part of this is like you learn in botany, why some of this stuff you almost think has nothing to do with gardening, but it's that kind of thing that whenever the things that help you to understand what's actually going on, because there's a lot happening in your soil and in your plants. So,
He rubs it between his fingers, just the way it feels.
the way it feels,
The percentage of the sand, silt, and clay.
That's it. Texture is the percent sand, the percent of silt, and the percent of clay. And the texture, as you see on that triangle, those different percentages will tell you what type of soil texture you have. Organic matter, it does not come into play for soil texture. It doesn't do anything for soil texture, because soil texture, by definition, is only the percent of sand, percent of silt, and percent of clay. What's the big difference between those three? Particle size. If you think of it in something that we can almost imagine, sand would be like a bus, silt would be like a Volkswagen Beetle, and clay would be like a Matchbox car, all compared to each other. Clay particles are so small that you can't see individual clay particles without an electron microscope. A regular microscope, you can't even see the individual particles. But they are very important because clay actually holds more water than the other two because there's so much surface area, and it has better charges. It improves the CEC of the soil and actually will hold more nutrients in the soil and make them available for your plant. So growing in straight sand or in straight silt, not really good. You want a mixture of all, but you don't want too much clay. So texture is the percent sand, silt, and clay. And this lab is a quick exercise on how you can determine what your soil is. Is it a sandy loam? Is it a silty loam? Is it a sandy clay? All that, these different categories that they give you on that triangle. So with that, everyone who brought soil with them, my lab TAs hand each person a water bottle, a full water bottle. And this is how you would do it. Now, I'm using the water bottles here. The better is something like what she brought her soil in. She would actually probably be better not even to use a water bottle. Just pour water from the, is that yours or hers? Yours, okay, yes. Just pour water into the jar, because mason jars like that are the best to do this lab with. And so when you get your water bottle, drink about half the water, and then put about a cup of your soil into the water bottle. It's the heaviest, it sinks the fastest. Silt sinks the second fastest rate. Clay sinks very slowly. So when you put your soil in your bottle and shake, put the top on, and shake it really, really hard so that all the particles get evenly wetted. And then you can pour that in here. And you can't pour it in a plastic bag, so it's not going to fill. You want to get it into the bottle. Now we'll take a little work in a small mouth bottle. After we did the lab this morning, I said, all right.
Do you mind if I use some of your soil?
What I find is, as you mix your soil and shake it really hard, you can see stuff start to settle and probably make a layer at the bottom. But the lab technicians are right now are passing around some bottles, and these were filled with soil and shaken vigorously about 18 hours ago. And on some of those, you can see that the water is still pretty cloudy on top. That means there's still clay in that water that's still settling, even 18 hours later. And so, ideally to get really what your soil texture is, you want to let it settle until that the layer of water is more or less clear. You don't want a lot of murkiness in it. That can take anywhere from 2 days, some soils, maybe a day and a half, others 2 days. But so what we're going to do now is the soil you brought, go ahead and put your label on your container, your name on your container. We're going to set those over on the shelf and let them settle until next week when you come back. And then you can see what we're talking about, and then you can actually, if you want, do the soil texture on the soil you brought. Yes?
It's right here.
You mean a finished one? Yeah, we're putting about 2 per table. Yeah. And so the TAs, what they're doing right now, and don't shake them, TAs, they're passing around those 2 that have been settling for a while. So now we're going to use those for you to do the lab to actually determine the soil texture. So work in, groups or pass them around. And so I'm sure most of you watched the did all of you watch the soil texture lab exercise video yet? If you did, then you kind of know what we're talking about here. If not, we're going to go over it quickly. But you're going to, what should form basically in a really good soil, you'll definitely get 3 layers. If your soil is not so great, it's got too much of one thing or another, you might not get 3 layers. And what it should almost always look like is the sand layer, usually not the most. The silt, a lot of times, is the biggest layer. That can go back and forth. But the clay layer in good soil should always be the tiniest layer. And if you're looking at your bottles and seeing what the 3 layers, if you can see the 3 layers, what you're going to probably see is that clay layer, it's almost not measurable. It may only be 1 millimeter or 2 millimeters thick. And so what we're going to do is measure those 3 layers. The depth of the sand layer would be from here to where the sand silt barrier is. The silt layer would be the difference, the length from here to here. And then the clay layer, of course, is this tiny layer on top. And so you'll have your sand layer. Let's say your sand layer is probably, see if I can get these proper, to make them add up to what I want them to. Your silt layer might be 50, and your clay layer might be 10. Let's see how I made these numbers up so I can make my math real easy. And when you're measuring, especially in small units, small quantities of soil like this, I like to use the millimeter measurement because it's tiny fractions, it's tiny units of measure. Now, as far as measuring, you can measure with anything you want. If you want to try to calculate, you might say, well, my sand layer is half a pinky, my silt layer is 3/4 of a pinky, and my clay layer is 1/4 of a pinky. It's not the units that are important, it's the fact that you can measure and have them all expressed. And so, this, I would say, is millimeters, but I don't have to write it down there. All I'm interested in is how many units. And so, now you can see that, so my total volume of soil that I'm measuring as far as texture is concerned is 100 units. And so, if I take, you guys all know how to do percentages, 40 divided by 100, that means I have 40% sand, 50% silt, and 10% clay. You can see it does add up to 100. And so that's 100% of my volume. So now on my triangle that I have, I would go and I would find, okay, my sand percent is 40%. I would find 40 down here on the bottom, which is where the sand is, and then follow those parallel lines or draw one parallel to those lines, going from the sand to the clay. And then I would look at my silt, and silt is 50%, so I'd find 50% on my silt base, and draw the line from the silt toward the sand. So it's sand to clay, silt to sand, and then my clay, I draw that one, find 10%, and it's draw the line from clay to the silt. And if you do that, there will be a point where all 3 of those intersect, and then in your triangle, it will tell you what type of soil you have. It'll be something like clay, sandy clay loam. Those are all actual true textures for soil that have been defined by the different percentages of these different parts in those. And so whenever you're reading something and it says, you know, you want a soil that's a nice, maybe they say sandy loam, and that's usually good for everything. You'll actually know, well, to get a good sandy loam, you can look at your triangle, and if you actually could get the different parts themselves, the sand, the silt, and the clay, you can make your own sandy loam because you know what it takes to do it. And you can see some of those are pretty broad texture varieties that encompass a lot of different percentages. Yes?
Why isn't there water at the top? Would even the clay settle below some of the water?
The clay will settle, yes. And this all up here, sorry, I should have put a line there. This is all water up here. And what you can see in some soils, when you're testing them, is you might see this layer, and then you might see some particles of stuff on here or some particles up here floating around. That's the organic matter that's in the soil. It's not going to settle out, mostly, none of it's going to settle out into these. So you might actually see another layer up here of material that looks different from these three here, and that's organic matter, but we're not interested in organic matter in determining soil texture. Now, is all that clear as mud? So you should be able, with the models that were passed out to you, that the soil's been settling for about, like I said, 18 hours or so. You should be able to see easily 2 layers, and several of them may have that third layer very thin. And usually the sand layer will be kind of light in color. The silt layer will be usually a little darker for some reason. And the clay layer will be very light too. And a lot of those I've seen, the clay layer is almost kind of a light tan color. The sand will be sandy brown and the silt will kind of be dark. So some model like this,
I'm gonna measure using centimeters, right? So I'm gonna measure the total first. And so that looks about 9.5.
It kind of goes
Total
from like solid ground
is
to
9.5 centimeters, okay? So
I
how
think
much
that's the
is
clay.
the
Well, you
clay?
can see it real
I mean, the
good.
sand layer is about to there, right?
It's about 5.5.
Yeah,
5.5?
there's a little separation layer right there. And then all the rest.
And then the silt,
We got a lot of sand in this one. I think
silt
up to
starts
like
about right there.
this sand.
Goes up to there, 2.5, about 2.5.
Silk, he said it's darker.
So there's 40, 50 tins
then
down. Does that mean like
made up clay
in an
layer.
ideal soil, or just like for example?
Maybe it's not the
About 2.
The one that you
It's
have,
probably all clay dissolved in here.
is still kind of cloudy with what's on top.
So we're gonna add these
For the
together.
lab and for the exercise to figure out your percentage,
5.0 centimeters.
measure your sand layer,
6,
measure your silt layer,
We'll keep
and
up
then
with
say,
100.
okay, my clay
Okay,
layer
so
is about
we have 10
5
centimeters, right?
millimeters. Just counting as 5 millimeters. If it's still a lot of cloudiness.
We didn't have the 9.5, we said 9.5, but somehow we added up to 10, so let's go with 10, okay? So, we're gonna see what percent each of these is of that.
Okay, so 5.5 out of 10.
Divided by 10, it's easy, you just move the decimal place 1 point, right?
Is it like made up of the
0.55.
same things? Like,
0.25.
like more like
0.20.
typically or whatever. It's just the
Yes.
size.
Okay,
is
so we have
The
55%
question was, so we had,
sand,
just so everyone,
These are
does
percent.
the benefit from everyone else's questions was,
55% silt.
with sand, silt, and clay, are they all the same material, the only difference is size?
So, we start over here. with
Primarily,
clay.
they're all the exact same
20%,
material.
So we
They
draw a
come from
line.
the same
right
parent
across the
material,
bottom of that
and as
line.
they're broken down, it's the size that makes the
And then
difference.
our silt, we start over here, and it's 2.5, so it's way up here.
Well, I was wondering, like, is it
25%, so
certain
right
like,
here, right? And
is
we
it like
follow these
iron
lines
that
down
makes
here.
sand
Six,
sink
exactly.
or whatever?
That's about-
It's not apparently.
That, okay.
That's what he
And then our
said.
clay is 20%, so
Like 22 or
road,
sand
it's silt,
and
the
clay
sand,
are
right?
really the
So
same
here
thing.
is
just
sand, and
different
it goes.
particle sizes. I never would have.
Which way does sand go? I forgot.
Right.
Sand would be
I
silver.
think I did silt. Silt this way, right?
Be something else.
Like,
Clay went this way. And
yeah.
which
I would
way
have
do we
too.
draw the sand one? I forgot.
So I guess what he's saying is once it does settle, it's
So what's
gonna
the
have a
difference in
whole
like
bunch of clay.
black sand and white sand?
Do you remember which way to draw the sand? Remember which way to draw the sand? We got our clay going this way.
Go from the sand to the silt.
The sand to the silt.
I wrote mine.
Okay, so it's 20%.
I'm not sure. Yeah, it seems like it. Walking on it at least.
Yeah, but that only goes right there. It doesn't intersect our lines.
Those people.
You know,
We're supposed to
black
go
sand
this
is
way,
probably
this
mostly
way, and
like
this way, right? Silt from here, 25
black
down to
sand
that
is more
way.
from like volcanic
Clay
type
goes
stuff,
this
and
way.
white sand is more like
Sand must go this way.
Yeah, so let's go with clay.
Yeah.
That's probably
So 55%.
maybe beach sand is different than just your regular.
Yeah. So our lines intersect
Right on the
See.
right here.
So.
Somewhere between a loam and a sandy clay loam.
I didn't follow that at all.
30. Oh, excuse me. You're right. Then we do silk.
Your triangle, one of those hands-out actually tells you which direction to draw the line. It's, there. It's this one, this page. It says, drawing your lines. Because with that triangle and the way everything goes together, it can get confusing. Because if you were to draw your sand percentage to your silt line instead of to your clay line, it's going to mess everything up. Your lines won't actually intersect. They might end up one going this way, one going this way, and one going this way, and you wonder what the heck happened. You have to draw them in the right direction. The second lab, and that's the one where you have a sheet that has 2 tables on it.
No, it's like right and left.
Can I borrow this? These 2 are the sheets for your second lab. The one that has the 2 tables on it, and the one which actually is a soil test analysis results.
Oh no, that's way too easy.
So with this one, so you guys all, I'm sure you guys have all watched the videos on soil already. So if you get a soil analysis back like the one you have in front of you, and it says phosphorus very high, is that good or bad? Good. Good. NPK. So it's important for you as master gardeners to understand and be able to interpret a soil test analysis, because Anna will tell you there's a couple of times a year when people usually do soil tests just because they're starting their garden in the spring, maybe they're starting their garden in the fall. Homeowners, a lot of times they'll do soil tests at that point in time. And invariably, we get, it wouldn't be an exaggeration to say we get 100 calls for people to ask us, okay, I got my soil test analysis back. What does it mean? Or they'll call and say, on my soil test analysis, it says the calcium is very high. Is that bad for my plants? What can I do to get rid of the calcium? And that's because they don't understand what the soil test results are giving them. And because our soil test lab isn't sending them those types of information. But on anything except pH, if it's high to very high, you guys know that's good. That means you've got plenty of that nutrient in your soil. You don't need to add any, especially if it's very high. That means you got enough to produce this one crop that you're growing, and should probably be enough to produce another crop that you're going to grow in there. Essentially what it's telling you is if it's high or very high and you add phosphorus, say we're talking about phosphorus, if it's high or very high and you add phosphorus fertilizer to your soil, you're not going to see any results. It's not gonna make the plant any bigger or grow any faster because it's already got all the phosphorus it needs. Now, they don't do a nitrogen test with your soil analysis because nitrogen is very water soluble. I'll learn that in the video. And so that's why they don't do a nitrogen test, and they'll always recommend adding nitrogen because it doesn't stay in the soil. Nitrogen you will need to add. But sometimes you don't need to add phosphorus or potassium, so it's really a waste of money. And in some places, you guys have heard some things where excess phosphorus fertilizer has been used, especially in fields where the runoff can go into rivers and lakes, and there's phosphorus buildup in the water as it runs off from the fertilizers. So those numbers, the only one on a standard analysis that can be damaging if it gets too high is sodium. However, sodium has to reach extremely high levels before it becomes damaging, and they actually classify those as sodic soils. That means the sodium salts in there are so high that trying to grow anything in there, I mean, you would know if you had sodic soil because you wouldn't be able to grow much of anything in soils like that. They have to be leached extensively before they can be used for growing stuff. So sodium, you can even get results that'll say extremely high. And okay, I know my sodium's still not high enough to cause any problems. And so with all those, now with pH, that's a whole different thing. Optimum is what you're shooting for in pH. However, in our area, most soil analysis will come back and the pH will be slightly high. In the greater New Orleans area, the soils tend to have a higher pH. If you go across the lake and check soils up there, a lot of those have low pH and they're acidic. And so the exercise you got right now is, I think it's 6.79 is the pH that you have in your analysis. Calculate using the tables that are on the other sheet, calculate how much aluminum sulfate is one amount. You're using aluminum sulfate or you're using elemental sulfur, but calculate how much aluminum sulfate you would need to add to your soil to bring the pH from 6.7 down to 6.0, or how much sulfur you need to add to bring the pH from 6.79 down to 6.0. And your garden is 10 feet by 40 feet. So now you can calculate the square footage, and based on those tables, it tells you how much you should use so many square feet. And then you can calculate how much of each one you would need to add. Huh?
I'm not following.
That is a pH that you got back of 7, so go from 7 to 6. That'll make it easy for you to work through it. Because the important thing is that you understand the concept of how to do it and how to make the calculation.
Get it right?
I have no idea. Please don't give us this in the test.
I'm not understanding that.
As far as the desired pH though, would it be 0.3?
Okay, I am